I'm sure everybody is already familiar with David Seuss. He I got to know him during one of Rachel Christie's meeting, and he is a dear brother and believer in Christ. He owns a company, a data analysis company, should I say?
We build custom search engines.
Custom search engine.
Yeah, for large companies to use in their research functions.
I see. That part of it, I would like you to describe a little bit more. Is that you, the company, for the purpose of marketing, go to you and ask, hey, can you give me research about this demographic thing, about whatever, and then you have to come up with
we don't conduct primary research, but if a company, take Merck. Merck is one of our clients. Merck executes 1,000 market research report studies a year. These are big studies, and we host all of the research reports that come out of that and search it and make it available enterprise-wide for Merck. We have clients in other industries too. We have IBM as a client, Intel as a client, Adobe as a client, Vanguard, the mutual fund company, is a client, USAA, GlaxoSmithKline. So we have Caterpillar as a client. We have about 40 clients. And sometimes the research that we're serving up is market research. Sometimes it's competitive intelligence. Sometimes it's scientific research, technology research. But we don't conduct the studies, but we host the content and we search it, and we give the search engine knowledge of the business purpose of the search, so that you can, with things like machine learning algorithms and things like that, so that we can give better search results and do other things with the content that straight search can't do.
So
I spend my days trying to teach computers to interpret text.
Yeah,
it's a hard problem. They're not that smart.
They're not that smart, huh? So it's like if you give computer a book and say, hey, just read the book, computer, read a book really quickly and give me the results of what
I should know. Yeah, we summarize documents, and we summarize search results across documents. So the user does a search, and then we write a report on what the documents had to say that was important.
So how do you think
it's the document search? Go ahead.
So how do you think of yourself? Are you a computer scientist or a data scientist?
I'm a natural language processing scientist.
NLP, okay.
NLP.
Okay. I do audio front end, so that goes right before your stuff.
There you go. We transcribe that automatically and then search it with our stuff.
Oh, nice.
Speech to text has really arrived. It works now.
So David Seuss, in our culture, language control the culture, right? So the language keeps changing its meaning. So if I say I'm oppressed, the word oppressed, okay, search, do analysis. What does that mean? You read a book and there are 500 words oppressed in there.
Well, you could try to search, what does it mean to be oppressed? And we couldn't actually answer that, but we could tell you what the consensus of opinion is about what it means to be oppressed.
Oh, even
that we could do. We could surface up a knowledge graph on oppression and what the commentators said who contributed the documents to our repository. We could tell you what they thought.
That's very interesting. Well, okay, so let me begin with the prayer first, and then we can start the discussion here. Father, we thank you for today. Give us a wonderful day here, at least in San Diego, and I hope other part of the country, here we are enjoying a wonderful day. And thank you for time and technology so we can get together via Zoom to share some of the very important information about how wonderful you created this world through fine-tuning. Father, we just pray for this time of fellowship and listening to David Seuss' presentation. that you bless our time. In Jesus' name we pray. Amen. All right. So let David, you can take over.
I'll take it away. I have two questions. One is remind me what your time window is. I have a lot of material, and so I need to keep an eye on the clock.
2 hours.
Great.
But of
Very
course,
good shape.
yeah.
I've got a good hour presentation, and I'm going to try to pause and have discussion, and it will expand. So that's perfect. My second question is, are there any physicists in the crowd? So I can apologize in advance. All right, Chuck. Keep me straight. And I hope I don't cause you to run screaming from the room, since I am not a physicist and I'm going to be discussing physics.
John Ray is a physics teacher.
Super. You need to enable my screen sharing, David.
Okay.
That's so beautiful. San Diego is such a great town.
Wait a minute.
We're looking at your screen right now. You shared your screen instead of enabling screen sharing.
Okay. All right. Let me see. Security here. Okay, there you go.
Minus this maybe. Okay, can everybody see the PowerPoint slide?
Yes.
Yep.
Okay, so by way of background, I am personally interested in exploring rational arguments for the existence of God that do not depend on scriptural inerrancy or personal revelation. I don't think I'm enough of a scholar to truly interpret the Bible. I read books by people like John Walton, and I think I need to have John Walton sitting there with me in order for me to understand what it really means. And also another person's personal revelation can't be mine. It can only be the other person. So I'm looking for other bases for belief and faith. And this is sort of my current working list. Human consciousness, and it's the great mystery of human consciousness, the hard problem. The mathematical structure of the universe and our ability to understand it, which actually baffled Einstein, among others. Human conscience, human longing for purpose, the appreciation of beauty, free will, quantum mechanics, and tonight's topic, fine-tuning. And there are many Christians and Christian apologists and Christian leaders who believe fine-tuning is the strongest of these arguments. And so it's really worth us spending some time talking about it. Now, while I'm going through the presentation, these will be the discussion questions that I would like you all to think about and be prepared to comment on and debate. When we get to the end, I'll just put this slide up and we'll have at it. So how important is the origin and evolution of the physical universe to any aspect of your faith? Sort of a good question. Many people think these questions, the origin of the physical universe is not that important, and their faith is based on other considerations than where did it all come from. Many Christians take comfort in the fine-tuning argument. Others don't really care. After we've gone through the presentation, I'll be interested in hearing where you come out. Are you concerned at all about the nature and content of the popular media discourse on cosmic origins, which is usually universally hostile to theism? Many Christian apologetic leaders feel that fine-tuning addresses the public impression that scientifically based atheism explains everything in terms of cosmic origins. And is this public discourse on fine-tuning important, and are the apologetics arguments convincing? And really, should Christian leaders take such a stand in favor of fine-tuning? All right, just to set it up, I think we should turn to popular media as long as we're talking about it. And I think the reason that we care about fine-tuning is expressed best by what I call here that most modern of American philosophers. She's actually a very popular singer-songwriter and one of my favorite artists, Brandi Carlile. If you all are not familiar with her music, I encourage you to learn about it. But she has a song called have you ever? And one of the verses goes like this: have you ever stared into a starry sky? Lying on your back, you're asking why? What's the purpose? I wonder who am I, if you've ever stared into a starry sky. And I think that's ultimately what the fine-tuning argument is talking about, who we are and what the purpose of our existence is.
And can you introduce fine tuning? Oh, here you go. Okay.
Yep. So what is it?
Yeah.
So what fine-tuning is and what it's not. So fine-tuning discusses what combination of the physical constants in our universe would create conditions allowing for intelligent life in any form to evolve, and how probable it is that the constants will have these values in a process to select them in a random event in the Big Bang. So the argument is that life-permitting conditions are very improbable, and the fact that we're here is evidence that it wasn't random and purely physical, that God intervened and caused the universe to be the way it is. So it becomes an argument for God. Usually commentators focus on the issue of conditions that permit three things: matter to form. So if it's an all energy universe, if the constants were different, you might have an all energy universe with no matter. For chemistry to exist, which is generally regarded to require atoms. So if you have conditions in a modeled universe where chemistry can't exist, it's assumed you can't have intelligent life. And also we have to have third generation stars that have long lives, because the formation of heavy elements requires third generation stars with long lives. Otherwise you get a universe with just hydrogen or helium, or hydrogen and helium, and the presumption is that would not support intelligent life. Now the above is a very high bar. It allows for intelligent life that is very different from ours. It would allow for silicon, for example, silicon-based life instead of carbon-based. But whatever completely different life could form is, from what we know, it still is presumed to require matter, chemistry, and third generation long life stars. Now there's a related set of ideas that fine-tuning is not about. One is how probable life is on Earth, given things like cosmic hazards. This is sometimes referred to as the rare Earth hypotheses by two Washington University of Washington scientists by the name of Ward and Brand-Lee. How probable complex life is, whether evolution alone could produce human-level intelligent beings. These are interesting questions, but they're not part of the fine-tuning discussion.
So is the thinking, when the Big Bang happened, you roll the dice and then you get the speed of light?
Mm-hmm.
Okay.
Yeah, that's it.
So that the physical quantities or constants would be different. Okay.
Yeah, that's exactly correct. We'll talk about the speed of light in a couple of slides. So that's one of the best examples. So I like this. I sort of paraphrased Genesis. In the beginning, God said, "Let there be fine tuning," and there was life. And the history of fine tuning goes back really to 1802. We're all familiar, you're all familiar with William Paley and the watchmaker analogy. He finds a watch on the beach or something, and he says that it seems if you find a watch, you can either assume that it was made by a watchmaker, or you can assume it was, some random process created it, and the watchmaker is a better argument. In 1913, chemist Lawrence Henderson wrote The Fitness of the Environment, that pointed out that life depends entirely on the very specific environmental conditions on Earth, especially regarding the prevalence and properties of water. And then in 1961, physicist Roger Dickey, who was the Albert Einstein professor at Princeton, observed that gravity and electromagnetism must be perfectly fine-tuned for life. And he coined the phrase fine-tuning. Since then, hold on, I'm having trouble with that. There we go. Since he coined the phrase and suggested cosmological implications, fine-tuning has attracted more and more serious scientific interest. I plotted the citations by year in the Stanford Encyclopedia of Philosophy. They have a great page on fine-tuning. You can see how it starts in 1960 and then takes off through 2010. Now, the last time segment here doesn't mean there's a falling interest in fine tuning. If you always, when you plot these things, the most recent time period is smaller than the one before. And it's just, it hasn't been enough years yet for, say, an article written in 2020 to get cited. I'm sure if we were to go out 10 years from now, we'll see that the articles that were written in that decade are probably going to exceed the ones in the prior decade. So it's been attracting a very great amount of serious scientific interest. This is articles talking about fine tuning in peer-reviewed physics journals. So let's talk about the constants, because we're going to spend a lot of time on them. And what is a constant? So there are calculations, there are proofs, there are laws, and there are constants. So a calculation is 1 + 2 = 3, and that statement is presumed true in all possible universe. A mathematical proof would be the value of pi, which is the area of a circle divided by the radius squared. Mathematical proofs start with axioms that are given as true, and the conclusion is logically proved to be necessarily true given the axioms. Proofs are not part of the fine-tuning debate. We're not talking about pi here, because their logic will be true in all universes given the same set of axioms. A physical law is E = mc². And it's possible that there would be universes where E = mc³, but that's not generally part of the fine-tuning debate, in part because no one knows how to evaluate that. We use the physical laws to evaluate the probability of a universe being life-supporting, and if we don't have those laws, we don't sort of know how to do the calculation. And that now brings us to the constants, which are the subject of the fine-tuning debate. So a constant in physics is a number that must be added by hand to an equation to make it conform to experimental outcome, or which is a physically measured quantity. You can actually argue both of those criteria are the same. So that's one way to measure a quantity, is to do an experiment. So they just are measured, if you will. Constants are not determined by any fundamental physical law. They cannot be derived or calculated from theory. They just are what they are. A classic example of added by hand is the logical constant, adding, taking out a to make the change about the expansion of the universe. And in our example, E = mc², the physical constant is c, the speed of light in a vacuum. There's no physical law that states it should be 186,000 miles per second. It just is. And if you do measurements, you get that. And if you do calculations, you have to use that speed to make it conform to the observations that are made in the, if you do experiments, it would have to be that speed for the data to fit the experiments. Now, there are a lot of physical constants. This is a partial list. It's a pretty good list. It's about 55 physical constants. We talked about the speed of light in a vacuum. You can read down this. Many of these I don't even know what are. But the mass of electrons and protons and neutrons, the mass of the Higgs particle. I got myself off. There we go. Etc. So there are a lot of constants, things that measurements, quantities that have to be added to the equations in order to make them work. So let's talk about the core proposition of the fine-tuning argument. It goes like this. For intelligent life to exist, matter, chemistry, and long-lived third-generation stars must be permitted by the local laws of physics. Local here meaning in our universe. This plays out in a discussion of the constants in the laws, which turns out to fundamentally impact the above outcomes. There are three general evaluation methods or techniques used to determine if a set of alternative values to the constants would result in a life-permitting universe, those three being the standard model of particle physics, general relativity, and quantum mechanics. And as it turns out, the values of the physical constants of our universe that work to permit matter, chemistry, and long-lived third-generation stars are infinitesimally small compared to their potential natural ranges. So what happens when you move outside the light-permitting range of the constants? Really bad things. The analysis shows that particles never form in some cases. The universe is just energy. In other cases, matter does form, but not atoms, prohibiting chemistry and material organization of any type. In some cases, the gravity is so strong, the universe collapses into a gigantic big hole after its Big Bang and expands. Alternatively, it expands so fast, no galaxies ever form. In some cases, stars collapse into black holes. So the universe forms and stars form, but the stars themselves become black holes, or they never form at all. Stars burn out really fast in less than 10 million years. So life can't get started because you can't get that third generation with billions of years for things to happen. And lastly, stars never develop the ability to make the heavier elements. That's really related to the prior point. And so you end up with a hydrogen helium universe. So bad things when you're outside the life permitting range. So various writers have selected from that list of 55 constants and done their fine-tuning analysis. The 5 constants cited below, which we'll come to in a minute, are the ones discussed and modeled by physicist Victor Stenger, who we will also discuss extensively. The probability of the constant being randomly set to a light-permitting value is usually expressed as a fraction. The fractions below are reported by Victor Stenger and attributed to various Christian apologists, including Rich Deem and Hugh Ross, who of course is very strongly associated, I believe, with reasons to believe. So the 5 constants that Victor Stenger discusses and the probability they fall within a light permitting range is, or at least what he reports that the Christian apologists reported, would be the ratio of electrons to protons, which is a fraction of 1 over 10 to the 37th. If that was off by a little bit, those bad things would happen. Ratio of electromagnetic force to gravity, 1 over 10 to the 40th. Expansion rate of the universe, 1 over 10 to the 55. Same for mass density of the universe, and the cosmological constant, which Christian apologists have argued is fine-tuned to a level of 1 over 10 to the 120th. So combining the probability of all 5 of these being achieved in one creation event where the values are randomly chosen, you get 1 over 10 to the 307, which is, for all practical purposes, 0. Now, we're calculating a fraction. So to calculate a fraction, you have to have a numerator and a denominator. The numerator in the fine-tuning debate is the life-permitting range of the constant. And the literature implies that it is relatively straightforward for a physicist to calculate the impact of different constant values. If you change the cosmological constant and you know how to do the general relativity math around it, you can figure out if the universe will collapse into a black hole or not, or expand so rapidly that atoms can't form. So there's not really a lot of debate around the numerators. But what's the denominator for the range of values a constant might take if not fine-tuned? So what's the natural range that it could be? And the denominator is usually taken to be what's called the natural range, or their naturalness. The contents will, and usually the way it works is it's assumed that the value of the constant could be any value that will not break the standard model or general relativity or quantum mechanics or some fundamental concept like the Planck scale for energy, length, or time. So each constant natural range has to be specifically reasoned. It does appear doable. Physicists on both sides of the fine-tuning debate do this calculation. So they're not arguing you can't do it. So one example is physicist Luke Barnes in his paper, The Fine-Tuning of the Universe for Intelligent Life, which I have in the bibliography, a link to it. Really great paper. describes a parameter space concerning fermions acquiring mass from the Higgs particles, affecting, and in turn, which affects the mass of the up and down quarks as two separate constants, the mass of the up quark and the down quark. So he bases this analysis on a parameter space that can't be larger than a relevant Planck scale or smaller than would break QCD, which is part of quantum mechanics. And any value between those two extremes is presumed to be the natural range of the mass of the up and the mass of the down quark. The Stanford Encyclopedia of Fine-Tuning, Encyclopedia of Philosophy, on its fine-tuning page, also discusses naturalness, and they use a similar analysis for two other examples. And in those cases, they also use the Planck scale, but they use the standard model instead of quantum mechanics to set the other range. So that's sort of the approach. The approach is to say, well, how wide could this variable have a value if it was randomly selected, if the universe was rolling the dice? And then what's the part that's the life permitting range? And that's how the mathematics are calculated. Now, most physicists agree that the values of the constants in our universe are finely tuned. So Fred Hoyle, of course, the guy who's famous for the expansion of the universe, the list of anthropic properties, apparent accidents of a non-biological nature without which carbon-based and his human life could not exist, is large and impressive. Comment by the famous Stephen Hawking: the remarkable fact is that the values of these numbers seem to have been very finely adjusted to make possible the development of life. Sean Carroll, very prominent physicist in popular media. It is commonplace in discussions of modern cosmology to assert that the early universe began in a special state. I argue that the fine-tuning is real. Paul Davies: there is now broad agreement among physicists and cosmologists that the universe is in several respects fine-tuned for life. Freeman Dyson: the more I examine the universe and the details of its architecture, the more evidence I find that the universe, in some sense, must have known we were coming. I just think that's a great phrase. It's sort of everybody's favorite. The universe must have known we were coming. And then the famous Roger Penrose has this comment: how special was the Big Bang? This now tells us how precise the Creator's aim must have been, namely to an accuracy of 1 part in 10 to the 10 to the 1/23rd. Now, how big is that? That is probably the biggest number you're going to ever see. And in this case, it makes for the smallest number since it's in the denominator. But it's the biggest number you're going to ever see in physics, short of infinity. If you tried to write 10 to the 10 to the 1/23rd out at the rate of 1 digit per second, you would need 10 to the 17 universe lives in order to write the number out one time. It is a really big number. And so all of these physicists are basically agreeing that our universe is extraordinarily fine-tuned for life. Now, in fairness, Roger Penrose backed off of this statement when it was jumped on by Christian apologists. And he has said publicly, I no longer believe in that calculation. But at the time he said it, he did believe it. Now, theologians, too, have much to say on fine-tuning. So Francis Collins, who you might argue is a scientist and not a theologian, but when it comes to physics, he's a theologian. He's a biologist, of course. The chance that all of these constants would take on the values necessary to result in a stable universe capable of sustaining complex life forms is almost infinitesimal. And yet those are exactly the parameters that we observe in some our universe is wildly improbable. William Lane Craig, probably the most famous of the Christian apologist leaders, most active, most quoted, has this to say about fine-tuning. To say that the universe is finely tuned means that the fundamental constants and quantities of nature fall into an extraordinarily narrow range of values that enable embodied conscious observers to exist. That fact seems to be well established scientifically. Alvin Plantinga which I don't think I pronounced correctly, but at any rate, you know who I mean. It's as if there are a large number of dials that have to be tuned to within extremely narrow limits for life to be possible in our universe. It is extremely unlikely that this should happen by chance, and you, Ross, fine-tuning is 10 to the 43rd times more exquisite than someone blindfolded with just one try, randomly picking out a single marked proton from all of the protons existing within the entire extent of the observable universe. So scientists and theologians are talking about fine-tuning.
Are you going to talk some more about where those probabilities come from for each of the constants?
Yeah, I could do that. So, so let's take the ratio of electrons to protons. The methodology that's used in all of these cases is the same. You first figure out the life permitting range of the values, and that gives you some possible range of values.
Mm-hmm.
Then you figure out the natural range of the item, and that involves finding how small it could be without breaking one of those principles of the standard model, or quantum mechanics, or general relativity, or the Planck scales.
Mm-hmm.
And then how large could it be without breaking one of those?
Mm-hmm.
And that gives you the denominator. And so what you're seeing here in this case of protons and then you normalize it to 1 in the numerator. And so that's what you're seeing. You're seeing the natural range in this case, the range in which this ratio could exist without breaking one of those 4 things I mentioned.
So here's just my struggle with that. So I'm a electrical engineer.
Yeah.
Okay. And so electrons are flown around all over the place. Okay. And so you have 1 mole, which is like 6.02 times 10 to the 23rd.
Mm-hmm.
Okay. So you're basically saying, look, if there's 1 extra electron in 10 to the 12th moles, everything falls apart. Okay. That's like 1 extra electron in my whole neighborhood. And I'm like, there's never a balance of electrons like that. So I'm wondering, like, there must be something else. I'm not a physicist, so I'm wondering what that throws out.
Well, so first of all, they're not modeling it at this point in time necessarily. They might be modeling immediately the Big Bang, when some proton combine with some number of electrons to create some number of neutrons.
Got it. Okay.
And if that was off, then the universe doesn't work anymore.
Got it. Okay. So it's
you
not
have too many neutrons and not enough protons for our stars to have evolved.
Got it. So it could be some process in the formation of the universe, not like today.
It's not like right today. Most of this has to do with the inflationary period of expansion of the universe, because that set that set in place the structure that resulted in galaxies, stars, planets, solar systems, and matter first. There was actually a moment in the early universe when the first matter forms, so that's what they're looking at. If those conditions were different, would matter have formed? Would it have formed in a form? Would it have been created in a form when matter did come into existence that would result eventually in stars?
So if I could ask a question.
Please.
So what you're saying is that this fine tuning is not what we see, especially today. I mean, it's the result of the fine tuning, but the fine tuning is at the point of the creation.
Yeah, I think all of these are shortly after the creation.
Okay, yeah.
Very shortly after.
Okay, thank you.
We can track back, I think the time horizon goes back to 10 to the minus 43 seconds. And that is, before that, we don't know what happened. and after that, we have pretty good ideas about what happened and can model it.
But for the universe to remain relatively flat, the cosmological constant still has to be highly fine-tuned currently.
All 55 of those constants would probably have to be, including the cosmological constant. Well, the constants are not believed to change their values over time. If they do, then that's a, you know, that's a different universe. Science assumes that the laws don't change, that the laws are the same, and the constants are the same in all observable parts of our universe. I mean, let's take it as a given, because if you
Well,
don't have that, you really can't interpret experiments anymore.
well, yes, but to some degree, you know, the short lifers, you know, this is what they base their the young
point.
Earth. This is what they base this
Young Earth,
change.
the
However,
laws of physics change.
there is some possible evidence now that there has been some movement in the fine structure constant. You know, they're still investigating to see, but indications are certainly doesn't look like things have changed much. And it really helps us to be able to understand the universe if we can make that assumption that they don't change. If we can't make that assumption, then it really, really adds complexity to
It does.
to cosmology. But
Like the foundation shifts beneath your feet, kind of idea.
yes.
All right, so this brings us down, now we sort of know what fine tuning is and how it works. This brings us to the core proposition, part 2. Before the discovery of the Big Bang, the value of the constants could be taken as eternally existing brute facts. If you have a steady state universe that has never changed, whatever you see is just what you see. But with the Big Bang, there was a precise moment of creation when the exact values of the constants came into existence. And this now started to create the question of, well, wait a minute, if there was, and forgive my language because language breaks down really fast here. But if I talk about before the Big Bang, arguably time starts with the Big Bang, at least in our universe. So the word before the Big Bang is sort of a silly phrase, but I'll use it because there's no alternative but to say it. Before the Big Bang, the values weren't, the constants didn't exist, matter didn't exist, energy didn't exist. And then wham, there's this moment where they come into existence. Now you want to know how they got picked. And you have to address that question for the first time, because if it was a steady state universe, which is what most physicists, including most famously Einstein, believed in before the Big Bang was indicated by general relativity, and the expansion of the universe, then how were they set? So physics and cosmology have yet to develop plausible ideas for a process or physical law that explains how the values of the physical constants are fixed. So it's been decades. It's been at least half a century, more than half a century, since the Big Bang became the accepted interpretation of what we observe in terms of the universe. And really no progress has been made on coming up with a plausible explanation purely based on physics of how the physical constants are fixed. So the probability of the values of the constants being what they are by random chance in a single creation event is infinitesimally small. Actually, physicists initially suggested the values of the constants were set randomly when the Big Bang occurred. But then that led to this problem of fine tuning. And so the original idea that they were randomly selected was suggested by the physics community. And now the believers, the community of faith, comes in and says, well, that suggests a divine creator must have tinkered with the dials to prevent a universe where we could evolve. And this is the point where the argument for God from fine tuning enters the debate. Now, the impact of the fine-tuning argument has been profound. Like the discovery of the Big Bang itself, fine-tuning became a possibly strong argument for belief in God that appeared to be based in science. I think it's fair to say it's comforting to many Christians worrying about the relentless expansion of the claims of science, including and some of the ones who have Christian leaders who have supported Big Bang as an argument. Some of the quotes I read to you before, Craig, Plantinga, Ross, frequently quoted previously, frequently cite fine-tuning in writing and debates. It also has the advantage of engaging non-believers who claim to base their non-belief on science. You can have a discussion of science with a non-believer to suggest that there is room in physics for belief in God. And it convinced Antony Flew, who was the leading atheist of the 20th century, to become a believer. So I don't know if you all are familiar with Antony Flew or not. I don't know if you've read his book, There Is a God. But his story is a very interesting one. He was a student of C.S. Lewis. Imagine that, having C.S. Lewis as your professor. As an undergraduate, but thought Lewis's reasoning was flawed in mere Christianity. He wrote a critique of it. He named Theology and Falsification. I guess he got an A, even though he was disagreeing with his professor's thesis, which argued that claims about God were merely vacuous and they could not be tested for truth or falsehood. And this publication established his trajectory as a bright star of atheism. Excuse me. He wrote 43 essays, articles, and books. 42 of them proposed atheist belief as the only rational worldview. And his most prominent work was his 1976, The Presumption of Atheism, in which Flew forwarded the proposition that the question of God's existence should begin with the presumption of atheism. He wrote, "What I want to examine is the contention that the debate about the existence of God should properly begin with the presumption of atheism, and that the onus of proof must lie upon the theist." The impact of this, of his negative atheism, was illustrated by William Lane Craig in 2007. He made an assessment that the presumption of atheism had become one of the most commonly proffered justifications of atheism. And a BBC journalist wrote about him in 2010. This is William Crawley. Presumption of atheism made the case, now followed by today's new atheism, that atheism should be the default position and has no burden of proof, asserting that the burden of proof rests solely on the theist. So here's this guy who is creating the intellectual framework that leads to the new atheism that and he is the senior philosopher of atheism for the 20th century. But then he changed his mind. Between 1999 and 2004, he changed his mind and became a believer in God. He stated in letters he wrote in 2001, he leaked the change in 2004 in an interview with an atheist publication, and then he published the book, There Is a God, which I highly recommend, co-authored with Christian apologist Roy, I'm going to pronounce this Varghese. You all may know a better pronunciation than that, but I'll say Roy Varghese. He cited advancing science in two areas as his reason, the fine-tuning of the universe and the Big Bang. About the former, he wrote in a chapter that he titled with Freeman Dyce's quote, "The universe knew we were coming." The recent popularity of this argument has highlighted a new dimension of the laws of nature. In other words, the laws of nature seem to have been crafted so as to move the universe toward the emergence and sustenance of life. Let's take the most basic law of physics. As we calculate the value of even one of the fundamental constants had been to the slightest degree different, then no planet capable of permitting the evolution of human life could have formed. Virtually no major scientist today claims that fine-tuning was purely the result of chance factors at work in a single universe. And this just touched off a maelstrom of criticism from the atheist community. They really felt betrayed. Their elder statesman had become a believer. And the atheist community reacted vehemently and heaped accusations and criticisms onto Flew. Commentators claimed he was suffering from dementia, and the book was really written by Roy Varghese. They claimed the book contains arguments that Flew didn't know about and didn't consent to. They claimed the book used Americanisms, or Varghese is an American, and language that would not be natural to an Englishman. Flew didn't understand, the claim was made he didn't understand the science he was quoting. This is from Victor Stinger, who we're going to talk about more soon. In a later interview, Flew did not know, it was claimed, the work of the authors that he quoted in the book. Taking a last sort of snipe at him, can't attack the idea, you attack the person. The argument was made he was frail, and suddenly afraid of death, longing for an afterlife overwhelmed him. Now, Flew responded, I've been denounced by my fellow unbelievers for stupidity, betrayal, senility, and everything you can think of, and none of them have read a word that I have written. I have rebutted these criticisms in the following statement. My name is on the book, and it represents exactly my opinions. I would not have a book issued in my name that I did not 100% agree with. I needed someone to do the actual writing because I'm 84, and that was Roy Varghese's role. The idea that someone manipulated me because I'm old is exactly wrong. I may be old, but it's hard to manipulate me. This is my book, and it represents my thinking. Christian apologists rallied to his support. Biola University awarded him, given an award for liberty and truth. When informed of the award, Flew remarked, in a lot of my work and publications in this area and the criticisms I've received for changing my position, I appreciate receiving this award. William Lane Craig openly defended him in public settings and appearances. Anthony Horvath published letters written to him by Flew between 2001 and 2006 that lay out all the core arguments Flew put forth in There Is a God, refuting the idea that Flew's positions were not his law. In the bibliography, I'm going to give the slides to David for you all. Anthony Horvath's book where he publishes the letters is cited, and you'll be able to, it's really quite interesting to read the early letters and having read the book and knowing the controversy that was around it. So then in 2010, Flew dies at the age of 87, and it is reported that he was suffering from dementia at the time of his death. It's too bad about the dementia, and it was only 3 years after all of this was going on, because some of the people were saying it was the dementia that was causing the book to be read. But that ended Anthony Flew's involvement in the public debate around fine tuning, and the debate then shifted back to scientists. Anybody have any comments they'd like to throw in at this point? I think I should pause, and we're going to now go into a discussion of fine tuning, really the attack on fine tuning by a prominent scientist. And the part after that is the by no. So, anyone have any comments at this?
Well, this is Ray. I pointed out before, so everybody knows this, but it turns out that Anthony Flew debated Gary Habermas, I don't know, 20 years before his conversion, and they became friends. And Gary Habermas and Anthony Flew jointly wrote a letter or an article that's published in, I think, is Liberty University somewhere. That's very interesting, kind of a personal view of his journey, so to speak. So.
Oh, that is a great, I didn't know that. I'm going to I wrote it down on a yellow sticky. I'm going to follow up on that right after this meeting. That sounds like a very interesting additional piece of background.
Yeah, it was a 20-year friendship, and it was wonderful. But I can send the link to you.
Oh, that would be great. I'm David at northernlight.com. So that would be fabulous. Thank you.
Okay.
Any other comments before we press on into the attack on fine tuning by prominent scientists?
Well, if you could include that link to all of us, that would be great.
Well, I'll send it to David. Then I don't
Ray,
have to
just send it to me.
all right.
I can
Send it to
see.
David Wu, and he'll take care of it.
Yeah, he's a great guy.
Well, you can just put it in the chat and everybody will then have it.
Okay, three arguments against fine tuning. So we're going to now say, I mean, it seems compelling up to this point, right? I mean, the scientists are saying it's fine tuned. The theologians are saying, gee, that means that God must have done it. Anthony Flew, the most prominent atheist of our times, certainly an earlier time, has now, based on fine tuning, become a believer. Well, it's not that simple. So the scientific community raises three general arguments that say fine tuning, at least the religious implications of fine tuning, are wrong. Those three arguments are: first, the analysis of the probabilities are wrong. Secondly, future discoveries of a theory of everything will reveal a mechanism for setting the values of the constants to what they are. And third, the multiverse. So let's take them one at a time. The argument that the probabilities are wrong was really led by Victor Stenger. He was a professor of physics at the University of Hawaii. He had a focus on gluons, quarks, strange particles, and neutrinos. And he wrote or co-wrote 7 peer-reviewed articles in his 36-year career as a physicist. He did, though, write a lot about religion. And he wrote 17 popular books, 33 essays, challenging religious belief and promoting atheism, including one quite well-known book, God, the Failed Hypothesis, How Science Shows That God Does Not Exist. And in one of his essays, by the way, he attacks Anthony Flew's grasp of science. He singled him out. In 2011, he wrote the book, The Fallacy of Fine Tuning, in which he mounts an all-out assault on fine-tuning in general and Hugh Ross's formulation of the probabilities in general. He really goes after Hugh Ross in the book. Excuse me. So one of Stinger's main propositions is that commentators fail to consider combinations of the constants, where a change in one offset a change in one or more of the others. He also thought the range of the natural values and denominators were too wide, and instead of 60 orders of magnitude, should be more like 2 to 10 orders of magnitude. He built a software model, which he named the Monkey God, I think for the explicit purpose of insulting Christians. It was a tool for building toy universes with different values of the constants and seeing if they resulted in life-permitting universes, using one condition for judging whether the resulting universe would permit, and that condition was whether the resulting universe would permit long-lived stars. He then published the Monkey God at an open website for anyone to try, and used it to simulate different combinations of the 5 constants. Unfortunately, Monkey God is no longer available, so we can't go play with it tonight. And then he summarized in his book the fine-tuning fallacy with this statement. We have seen that the proponents of fine-tuning make serious errors in physics, cosmology, probability theory, and data analysis. While not every proponent makes every error, there's a remarkable similarity to the arguments you find in the theist literature, which leads you to suspect they do not do much research to support their claims beyond simply reading each other's books. So here's sort of the key point he makes, and it's referred to as the wedge. And so in this example, we have 2 constants, and we vary their values, and we can calculate the life-permitting range of the variables. And he observes the following. If you vary, say, the y-axis by a relatively small amount, you get out of the life-permitting range really fast. Or if you vary the x-axis by a relatively small amount, you get out of the life-permitting range really fast. But if you vary them both at the same time, you can move up and down the wedge. And now the life-permitting range is quite wide compared to what it would be if you only vary them one at a time. And his observation was that the prior discussions always varied one value at a time and never more than one. And he does this analysis. He runs 10,000 simulations, and using that sample, he estimates the fraction of universes generated that should have properties that allow for some form of life, not too drastically different from his own. And he comes out with the conclusion that between 13 and 37% of randomly selected values for the physical constants will produce life-sustaining universes based on stellar lifetimes as the criteria. And if this calculation is correct, it is pretty fatal to fine-tuning. Rolling the dice and having a probability of 13% or 37%, we can all imagine that happening. And suddenly our universe is not that unique. It's not that improbable. And fine-tuning is over as an argument. And this is the table from his book. He has this issue of the orders of magnitude. He varies in the column A, he's varying 10 orders of magnitude, in column B, 2 orders of magnitude. And he takes these different criteria and he calculates the percentage of the universes that would meet the criteria, and across all of the simulations he runs, it comes out between 13 and 37%. And this analysis is leaked into the popular mindset. I've heard more than one informed Christian apologist state the idea that if more than one of the physical constants are varied in concert with each other, then the assertion that fine-tuning is improbable fails. I've heard committed Christians say that. I've heard well-informed scientists who are Christian make that exact statement. And it's all flowing from this book, The Fallacy of Fine-Tuning, written by Victor Stenger. But then Luke Barnes comes along. So Luke Barnes is a lecturer and postdoctorate researcher in physics and cosmology at Western Sydney University. First in a series of posts to his blog, then in a journal published peer-reviewed paper that reviews the fallacy of fine-tuning, and then in his book, A Fortunate Universe, Life in a Finely Tuned Cosmos, Barnes challenges Victor Stenger's methods and the accuracy of the monkey god model. And unlike Craig, Wright, Plantinga, Ross, and Collins, Barnes is a physicist, and he can engage the scientific experts with equal training, knowledge, and mathematical ability. His basic argument regarding the correlation of constants in monkey god is that Stenger only considers one outcome of the covariate constants, and that is the lifetime of stars. Barnes argues that any set of changes have to be evaluated against all the outcomes that could be potentially disastrous for intelligent life, not just one. And in effect, Barnes is turning Stenger's method on itself. Stenger complained that apologists only varied one constant at a time. Barnes complains that Stenger only evaluates one resulting life permission condition at a time. And in his book, which is his paper, which is really excellent, and I cite it in the bibliography, and there's a link to it, The Fine-Tuning of the Universe for Intelligent Life, he has 9 conditions that he analyzes for changes in physical constants. And the reference to the lines you'll understand in a moment, because I'm going to show you a graph. But basically, in one of the conditions is and we're going to look at the mass of quarks and the analysis. And if they get out of a certain range, then only one element can exist. It has the chemistry of helium, so it would not be, there'd be no matter, and there'd be no chemistry. There would be matter, but there would be no chemistry. Another one, if the mass of the quarks is off by too much, protons are unstable, leaving no hydrogen left over from the earlier universe. We'd have a universe with no hydrogen, which would mean that nothing could exist that we would recognize, or that could be intelligent. So it has these 9 different criteria. So then he does his analysis. So we have the mass of the quarks, the up quark and the down quark, and he varies the value of them over a natural range, which he spent some time on, and that was the example I gave earlier, the reference I gave earlier. He comes up with the range of 60 orders of magnitude for their value based on not breaking the standard model and not breaking the Planck scale for energy, time, and distance. So he gets this natural range. And then he is calculating here the life permitting range. And what he does is, let's take the first one here, which was only one element can exist with the chemistry of hydrogen, or was it helium? With the chemistry of helium, if it's above this line. So anything below this line would be life permitting on this single criteria, which would be a very large range, as you can see. But then let's take the second one, that deuterium is unstable, preventing hydrogen burning in stars, okay? If you don't, that means no stars, right? So anything below is that. And then you work your way through it. It turns out the constraint, the ending up constraints are condition 6, anything above line 6, whereas 6, there it is life permitting. Values below 5 are life permitting. Here's 5. And values to the left of condition 2 are life permitting. Here's 2. And if you combine all those together, the only viable range is this little piece right here in the middle, which he then calculates out to be wildly improbable and not 13 to 37%, not even less probable than what the prior Christian apologists had calculated as probable for life. So his model shows how changing the value of 2 constant impacts multiple life permitting conditions. The resulting viable range of life permitting values of these 2 constants is smaller than anyone previously understood, because the additional conditions chip away at the larger area Stenger observed. And so the implications are not only that Stenger is wildly wrong, but the original formulations of fine tuning may have overstated the ability of random selection of the values of the constants being viable, making the case for fine tuning even stronger than previously thought. And Barnes sums it up with, of all the ways that the laws of nature, constants of physics, and initial conditions of the universe could have been, only a very small subset permits the existence of life. And this seems like a much more profound argument than the one that Stenger put forth. Now, Stenger responded. He issued a 12-page rebuttal to Barnes. And he said, pulling the quote out, one quantity of significant relevance to the fine-tuning question is star lifetime. I claim no deep results, but find it interesting that a wide range of fundamental physics constants will give long lifetime stars a likely prerequisite for life. Barnes makes his usual objections. Are you ready for this? To my admitted oversimplifications. Does he really expect me to simulate entire universes? And this is me speaking instead of Barnes, but my response to Mr. Stenger, Professor Stenger, had he said that to me, would have been, yes, if you expect me to change my religious beliefs on the basis of your model's results, you had better do the best job possible. One commentator on the debate between the two of them said, sure if Stenger and Barnes was right, he read Stinger's and convinced him Barnes was right. I think Stenger completely invalidated his position with his rebuttal, and the fact that his analysis simply didn't go far enough to present a reasonable conclusion that the fine-tuning calculations are incorrect. Okay, I'm going to go on to the next topic now. Anybody have any observations they'd like to make about the debate between Stenger and Barnes and whether or not the scientific attack on fine-tuning? What are your thoughts on this? Okay, I'll press on. So the second objection to fine-tuning is the hope of future theory will provide a means to derive the physical constants as having necessary values. This was the explicit hope of Einstein, and he devoted the last decades of his life to search for such a theory. In 1991, Stephen Weinberg, who has won the Nobel Prize for uniting the weak and the electromagnetic forces and figuring out what was going on in the very, very early universe at one point. He wrote a book called Dreams of the Final Theory, in which he laid out the features that a grand unified theory would by necessity have. Now then, if you fast forward for 20 years, I actually read Dreams of the Final Theory back in the 1990s, and I got excited about it. And I started following Steven Weinberg's writings. If you fast forward to 20 years, to 2009, and he has a collection of essays called Lake Views. And in it, he has abandoned all hope of a final theory with this astonishing statement in a chapter named, "Can Science Explain Everything? Anything?" Here's what he said. "Finally, it seems clear that we will never be able to explain our most fundamental scientific principles." It's really been a bad run for the idea of a grand unified theory of physics. This is a quote from the Stanford Encyclopedia of Philosophy on the fine tuning page. When you're, I find this page, by the way, to be very even-handed, given that, it's Stanford and we're talking about God and religion, and it's amazingly even-handed in its discussion. So sort of enemy territory when it comes to the faith, right? Stanford University. So he says, the encyclopedia says this: Einstein's idea that ultimately the laws and constants of physics will turn out to be dictated completely by fundamental general principles. That would make considerations about alternative laws and constants obsolete, and therefore undermine any perspective according to which these are fine-tuned for life. Unfortunately, developments in the last few decades have not been kind to the hopes of the sort expressed by Einstein. In the eyes of many physicists, string theory is still the most promising candidate theory of everything, in that it potentially offers a unified account of all the known forces of nature, including gravity. But according to our present understanding of string theory, the theory has an enormous number of low energy states. What they're really referring to is solutions to the string equations, 10 to the 500 different solutions, 10 to the 1,000 maybe, which would manifest themselves at the empirical level in terms of radically different effective physical laws and different values of the constants. These would be the laws and constants that we have empirical access to, and so string theory would not come close to uniquely determining the laws and constants in the manner that envisioned by Einstein. If there are 10 to the 500 solutions or 10 to the 1,000 solutions to the string equations, you're not helping explain why ours are what they are. You're just calculating the low probability a different way. And so the idea of a final theory, just to summarize, has most physicists today, or many physicists, or the sort of popular discussion in books and articles is we aren't going to find one. And we don't know where to look, and we don't have any good ideas. And we haven't made any progress on this in 50 years. So as an argument against fine tuning, it doesn't seem strong. And that leads us to the multiverse. So in the fine tuning debate, all roads lead to the multiverse. I know there are many versions of the multiverse, but we're going to restrict our discussion to a level 2, which is the most common way the term is used. A level 2 multiverse has an eternally inflating overarching cosmos from which an infinite number of bubble or island universes condense in local big bangs. And now we would be a local big bang, a local universe, an island universe, a bubble universe. Local bubble universes might have different physical laws and physical constants, chose randomly perhaps as random solutions to the string equations. Excuse me. It can be argued that a level 2 multiverse is the version that defeats the fine tuning argument, because an infinite number of the rolls of the dice is sometimes taken to mean that every possible combination of the physical constants will be realized. It might be 1 over 10 to the 12,000 or 1,230 power improbable, but if you get an infinite number of tries on it, the argument goes, you're going to hit it sooner or later. And you join that with the weak anthropic principle that says where our users explain nothing more than a chance event of the type where observers will evolve to wonder about it. If you have an extremely low probable event and an infinite number of tries, you will get universes, the argument goes, where people or intelligent beings evolve and then wonder what does it all mean? And, oh, it's so improbable that we're here. There must be a God. Now, level 2 multiverse is by far the cosmology favored by most atheist physics today. And here's a partial list of the prominent physicists who have come out in favor of the level 2 multiverse. Steven Weinberg, Martin Rees, Sean Carroll, Lisa Smolin, Alan Guth, who actually came up with inflation. And it's the mathematics of inflation that lead to the multiverse. Brian Greene, Lawrence Krauss, Max Tegmark, who MIT physicist who loves crazy ideas. And so it's the level 2 multiverse, the infinite number of rolls of the dice, that if there is a level 2 multiverse, fine tuning is no longer an argument for God. And that's sort of, this is the scientific argument that is most strong. Now, this leads me to one of my favorite observations by a renowned physicist Bernard Carr. He summarizes the fine tuning debate. He does it in one sentence. It takes me 41 slides, but he does it in one sentence. If you don't want God, you better have a multiverse. Now, Flew discounted the multiverse as merely shifting the problem up one level. He was, of course, aware of it. He writes at one point, the fine tuning has been explained in 2 ways. This is actually from the book, There Is a God. Some scientists have said that the fine tuning is evidence for divine design. Others have speculated our universe is one of multiple others, a multiverse, with the difference that ours happen to have the right conditions for life. What's especially important here is the fact that the existence of a multiverse does not explain the origin of the laws of nature. If there is a law of laws describing how parameter values are assigned as one slips from one universe to the next, then we've only shifted the problem of cosmic biofelicity up one level. Why? Because we need to explain where the laws come from. And it would be worthy of a whole meeting, I think, to talk about the multiverse. So I'll just make a few quick observations. There are many models of the multiverse, but they all share these qualities. The multiverse is implied by the mathematics of inflation, because once started, inflation doesn't stop ever. So inflation is this idea that immediately after a big bang, if you will, there is a period in which the universe expands faster than the speed of light. That's what makes it inflation. It doesn't violate relativity, special relativity, because it says the object, matter, can't be accelerated to the speed of light, but it doesn't say anything about space itself. And so the multiverse, in inflation, space is expanding faster than light. Once it starts, no one can figure out how to stop it. It is stopped at least once because we have our universe to look at. So if it can stop once, the idea goes it could stop locally over and over and over. And so then you get this infinite number of future universes condensing out of this overarching, inflating cosmos. So that's really part of every multiverse theory. There are 193 inflation models right now, by the way, but they all have this as sort of the background. There is for sure little, arguably no, direct evidence for the multiverse. There is the so-called cold spot in the cosmic microwave background, which is argued as 2 bubbles collided. Our bubble collided with another one, and it left this cold spot. But there are other interpretations of the cold spot, and there are also arguments that it wouldn't have left a cold spot. It would have left a big, gaping, gigantic hole in the sky. So there's no real evidence, maybe a little bit. But there never will be a large amount of evidence for the multiverse because all the other universes are beyond the light horizon of this universe. And using Karl Popper's falsification principle, something's only scientific if it can be falsified. The existence of other universes is not falsifiable. So speculating on them is arguably metaphysics and not science. And some observers have commented that the multiverse may represent the end of basic physics because it is pointless to study physical laws set by an ultimately random phenomena. If there is nothing more than it was rolls of the dice, then we can sort of stop looking for it. I'm going to close by with a quote from one of your neighbors in San Diego, physicist Brian Keating, extremely well-known, prominent guy. To me, this is the most distressing statement by a physicist I have read. I read it recently in Skeptic magazine, the most recent Skeptic magazine. And here's what he said. Many scientists today, especially young scientists, are deeply invested in trying to prove a particular theory. If we reach an era where acquiring experimental evidence to do so for inflation, and therefore, by the way, the multiverse, is forever beyond our technological reach, then other means, including social proof in the form of expert consensus, could become part of how scientific consensus is reached about such theories. In the post-Popper era, as unpalatable as it may be, social proof without experimental falsification may become the norm. So what he is suggesting is we'll come to a future where the priesthood of scientists will, without any requirement that they prove their assertions with evidence, will just be able to get together and decide what is true, and then that will be that'd be the nature of scientific truth. I truly hope he's wrong and that this idea fails. I will point out that in a survey of physicists conducted a couple of years ago, 3 of the top 10, the survey was, what ideas would you like to see drop from the modern discussion of physics? And 3 of them were, one was falsification, second one was fine tuning, and the third one was the hard problem of consciousness. And one almost wonders about the underlying religious motivation of physicists wanting to drop those ideas from the public conversation. So if you run into Brian Keating at the grocery store in San Diego, tell him, no, you're wrong. We can't do that. I will observe that if we used scientific consensus as our proof point, that we would still believe the Earth is the center of the universe. We'd still believe that you can tell if a person will be a criminal because of by looking at the bumps on their head. And I think we'd still believe that slavery is okay. And all of those crazy ideas would have had a scientific consensus at one point, and it was scientific method and experimentation and falsification as a concept that moved us to where we are today. And I'm personally extremely distressed to hear prominent physicists like Brian Keating suggesting that we're in a post-Popper era. This means we'll never have any ability to engage in science around things like the fine-tuning argument. Let's see.
Let me make a comment.
Please.
Brian Keating is sitting right in the middle of UCSD, bombarded by all kinds of postmodern ideology. So
Prominent, as a video series on YouTube. He's an influential guy. And he's not by himself when he writes something like that. He's not an original. I don't think he's the only one out there. I have heard Sean Carroll say he would like to see falsifiability dropped from the lexicon of scientists. All right, well, I've got 2 more slides and then it's going to be completely open. So one is this one. The Bible, this my party shot. The Bible says, now faith is the substance of things hoped for, the evidence of things not seen. In this sense, I think I observe or suggest that the believers that stare at the starry sky and see a purpose, and scientists that believe fervently in the multiverse that makes God and purpose irrelevant questions are very similar. Both have faith in something not seen. To me, it boils down to what you long for. Do you long for a universe that has meaning and value to human life, or do you long for a universe with no constraints on your intellectual freedom? And since I started with Brandy Carlisle, I think I have to give her the last say. One of the verses of her song goes like this. Have you ever wandered lonely through the woods and everything there feels just as it should? You're a part of life there. You're a part of something good. If you've ever wandered lonely through the woods. And I think that really speaks to the fine-tuning argument for me. It feels just as it should because it was designed for us with a grand divine purpose in mind. And it is definitely something good. So with that, I have nothing more to say. And I'd love to hear what you all think.
We open up to questions, comments.
Well, I have a comment.
Very insightful presentation. Thank you, David.
Yeah.
Go ahead, Ray.
Yeah. I think that you've pointed out something insightful in that last quotation from, I'm forgetting his name here.
Brandy Carlisle.
Yeah. No. Before that, the scientist here in San Diego.
Oh, this one.
Yeah. Keating. Yes. I mean, I think that is something that we see, I mean, in this whole debate, and I'm not going to go into all of it because I mean, we can be here forever, but this whole idea that it's an elite group of individuals that determine what truth is. And we see that, I think, significantly in this whole debate with COVID-19. And when, you know, someone says that if you challenge me, you're challenging science. And I just think that this is something that as Christians, we need to go back to what is science and what is truth. And this is this whole philosophical challenge to a theistic worldview that as Christians, we need to push back against that in our culture or we lose our culture. I mean, the idea that if we, science, if we proceed the way traditionally it's gone, that it's against critical race theory and that it's somehow racist and these ideas get thrown at us. And so anyway, that's my comment. Thank you, David, for pointing out Brian Keating's statement there, because I think that's something that we need to really have an answer for.
Oh, David, could we see the next slide, the one right after this, the interesting aside? The interesting aside, that one, yeah.
I did skip over this one, and I shouldn't. There's a really great debate between Sabina Hassenfelder, who is a physicist that I follow on YouTube. She has a great YouTube series. I read her book, Lost in Math. And she is herself an atheist, but she said in a video with debate with Luke Barnes, she said in her experience, scientists that believe in God are more careful keeping their religious beliefs out of their work than atheist scientists are.
That's great.
Isn't that interesting?
Yeah, that's great. Absolutely great.
Well,
Oh,
I have a comment. If Einstein and many others, Einstein in particular, had said the most amazing thing about the universe is that it is comprehensible.
Mm-hmm.
So the fine-tuning constants may actually still be a necessary requirement of the underlying physics, but the underlying physics is so far out of our reach that we can't understand it.
Mm-hmm.
Even if we could, I would just be more amazed by God.
Yeah.
Than, yeah, he dialed all these dials. That's one thing, but to build the system that, you know, that all these constants actually are required by the underlying principles that's so far from our understanding makes me more amazed.
Yeah, I think that's a very good point. Not only are the dials, specifically set, but he made the dials. So there, and another sort of place this intersects with another theme that I'm on right now. I think I presented on quantum mechanics to your group. And if you remember that one of the principles of quantum mechanics is that beyond the wave equation, which I happen to have on my t-shirt, beyond the wave equation, we can't know anything else about the universe. That will never go beyond the wave equation. That's it. The universe has drawn a line and said, this is all you're going to know. And that idea came up in the 1920s. And it's 100 years and we don't know anything more than the wave equation when it comes to that part of physics. And it's proven to be true, at least so far. And if this is it, if this is the limit, as you're suggesting, then we'll never find an underlying principle.
With the uncertainty principle, it limits our ability to analyze. We can't analyze anything that requires more precision than that.
Yeah.
I think one thing that is significant when you were earlier in your discussion, this idea of rejecting the ideas that have been the foundational principles and the individuals that have come before us. I think of Newton when he said that he was able to come up with what he believed based on the fact that he stood on the shoulders of the giants that went before him. It seems to me that the new science is saying that we reject all that and we're gonna build our own giants to stand on. I'm wrong.
They're becoming woke.
Yeah. And I think that that's something that also that we should, as Christians, as science-oriented individuals, that we need to say, why are we rejecting this wisdom that has come before us? And anyway, thank you, David. You made me think.
I think you're right, John. And it's a great point. But they're throwing out. So the first peer-reviewed journal was published in 1650.
Yeah.
And it transformed science. Suddenly, you had to submit your work to critique of other scientists. You had to have evidence. You had to publish your evidence. And it was suddenly different, and that is now being thrown out. We have 500 years, almost 450 years, 470 years of tradition here that has resulted in gigantic gains. But it's getting hard. Why is it getting hard? One is quantum mechanics and the limit. Another one is the energy required to do the research. So the LHC was supposed to find supersymmetry. Well, physicist Peter White said it won't have enough energy to do it. They will fail. They failed. Sort of made him prophet status. Now they're trying to expand it. And they'll say we'll find supersymmetry this time, which is necessary to prove to support the multiverse. If there isn't supersymmetry, the models that give you the multiverse fall apart. So this is a really big deal. Peter White has done a new calculation, which he has published, that says that the LHC will have to have the energy of the solar system to find supersymmetry if it exists. And he believes that the proponents of the LHC are lying about it in order to get funding. And because they need another $15 billion. So if you can't do the research anymore, and that's sort of what Brian Keating is saying, he's saying that the research to prove things or not is beyond our technological ability. What then? are we starting to hit this wall where quantum mechanics and the physical constraints on experimentation mean we won't make major advances in the future like we have in the past?
Well, and then it seems to, I mean, when we read in scripture where people, you know, where God is saying that how much people will philosophize against, you know, the idea of who God is and the whole worldview of what God and the creation of the universe. And, you know, that, and this is a futile, and you can see the futility of all these different philosophical approaches to determining what is the universe.
I think at the very least, fine-tuning creates space in science for belief.
I think so.
It demonstrates that the scientists don't have many of the big answers to the big questions, if they have any answers to the big questions. And we don't have to apologize to the scientific community for our belief.
No.
But that message is not out there in the media. If you watch the Discovery Channel, I mean, I get so mad at the Discovery Channel sometimes. Sooner or later, I'm going to break a TV. I'm going to throw something at the screen. You know, you would believe that the multiverse is an established fact, that we know exactly how life arose from chemistry.
Right.
That
But
you go down the list of things that are claimed in the media that just aren't true.
right. In terms of evolution, you know, we can't even demonstrate that we got the first pitch in the game. You know, it's like.
I'm sure you've heard the old joke about the scientists who come to God and they say, "Hey, we figured it out. We know how to create life. We figured out how you did it." And God says, "Oh, really? How did tell me what your method is?" And they said, "Wow, first you should start with some dirt." And God says, "Stop. Make your own dirt."
Yeah. Got it. That's cool.
That's very interesting. John, you are involved in high school physics, and it's interesting that at least the basics of fine-tuning, which we have evidences based on science and math, had not even made it to educational curriculum. You know, we still got stuck with Darwinian evolution and stuff that has been really a bogus. I mean, in my word.
Yeah. Well,
Argument.
as a Christian in a public setting, I was able to talk about, you know, the anthropic principle and talk about these things that so far as we've looked at the universe, that in order for our universe to exist, in which we can obviously explore, that these things have to be true. And I've had many students then say, "Well, Mr. Ray, well, what, you know, that seems to me that there's something more to the universe." And they've asked me, and of course, when I get to that point, I can offer my personal opinion. But there is hope, I hope. But the
You
problem,
must walk a tightrope, though. I think it must be very hard for you to walk that tightrope, because I mean, I can almost see protesters.
yeah.
It's picketing ass.
Well, you know, I mean, there's that old saying, kids don't care how much you know, they want to know how much you care. And so I think that was, I would hope that my students would have seen that in me. And so far, some of the evidence has been in that direction. And I don't, it's only because Jesus was in my heart, but.
There's been some commentator made the observation that no one ever converted. Now, Anthony Flew is the exception, but no one ever converted based on a scientific argument. That they convert based on the examples of Christians.
Right, and I agree with that. And I know that Chuck, you really bring that home a lot, and it impresses me too. Thank you.
Amen. I want to make an observation. I don't know if our people here in the panel had experienced or heard that or seen that. You know, we often think that the debates between the theist and the atheist, and the new atheist, they have a new arguments, but at least we have some sort of rules and some sort of logical debate. Our debate is based on the scientific principle and method, but there's a new extreme left coming in, and these are the postmodern ideology that comes in, embedded in critical theory and critical race theory is a subset of that. There has no reason, and it's all based on experiential narrative. So even the atheists right now, they are kind of trying to defend their position against this left wing, even more extreme left wing ideology that comes in, mostly through campus. And
Can you describe some of the principles of that new philosophy? I'm not familiar with it. Postmodern.
yes, basically, they've thrown out all the basic method and reasoning of our culture that have been there for 400 years. You know, right? Like we can debate logically with an atheist based on a logical argument, but now with the new trend, they have no logic. You know, all they want to argue is, oh, this is the science is a white man's idea. And so all argument that you have out of a window. So there's some trend that the atheist is looking for a partnership with theist to combat against this extreme left-wing ideology.
That's interesting.
That was a very interesting phenomenon, because I talked to
the different that when you look through when you measure the speed of light, you get a different measurement if you're one race than if you're another race. Is that the idea?
That's correct. You look at the sky and they say the sky is blue, and a person would say, well, it's blue for you, but it's gray for me. How do you argue that?
I might be able to argue that one, but I couldn't argue what the wavelength of the light coming from the sky was. That would be just a measurement.
I have a comment in kind of like, in one sense, maybe in a transcendent sense, we believe in a multiverse. That we believe that there's God's creation universe, and that there is a realm in which transcends us, that in which God is God's domain. And so in one sense, we believe in the multiverse.
I think quantum. I think it's a mistake to look for scientific links to core beliefs.
Yeah,
sometimes, but quantum mechanics has this idea of entanglement, which the thought has occurred to me that opens up a really easy reality for the soul.
Yeah. I agree. That's cool.
We could be entangled with particles in a different dimensionality, and it just works as an idea. I mean,
yeah. Well, in the sense that, you know, God, our creator, is in charge of all those things, and Christ could come through the closed door, you know, and appear in a room without having to go through the door, you know. But the rest of us can't do that, you know. I know that I forget. I was reading Schaeffer, where there was an author or maybe it was, anyway, he had the people coming in through the window as opposed to coming in through the doors, and but they still had to come through something that was connected to reality. They just didn't come through the solid doors and through the solid walls. So anyway.
I have a question. Do you guys have any idea what is the average, I would say average US population? I know that's including Christian and non-Christian who are aware of this fine tuning at all. I think it's very small percentage of people.
Yeah,
For one reason, the popular media will not give it any weight. They'll talk about the multiverse only.
right. Well, and if you put that on your YouTube channel, they'll probably censor you and demonetize you. And
And I have a personal concern about the public discourse on these topics. I don't know what to do. I guess if I had the money that Bill Gates had, I would try to change it. But you know, buy the Discovery Channel and change their editorial philosophy or something. But you'll never see a popular song. You won't see a Nova on fine tuning. You won't see a Discovery Channel program. You'll see things on aliens, flying saucers,
yeah,
on Bigfoot. You know, the multiverse and
and every time we
origin of life chemistry.
right, and every time we find a new planet, the next comment by the general media is that are we alone?
We can't be because there's so many planets, right? And there's so many
Right.
stars. That's the argument. I saw an interview on TV with the U.S. commander of the U.S. Team that was on the International Space Station a couple of years ago. I mean, this is a serious woman. You know, she's an astronaut, and I admit that NASA has a business model around this, and maybe she was just being a good employee. But in the interview, she talks about how there has to be life on other planets because there's so many other planets. Starts with the exoplanet example, which you guys had a wonderful presenter on that topic, and completely ignoring the rare earth hypothesis that rips the Drake equation to pieces and makes it irrelevant. But
I had a personal experience related to that. I had just finished reading Brownlee and Ward's book on rare earth, and I was involved with a NASA program that connected high schools with a radio telescope in there in California. There at the where anyhow. So there was a large contingency of individuals that I was connected with through NASA. And I mentioned to them, because we got on this discussion about, using all of our energy to explore the universe and find life in the universe. And I said, well, what do you think about Brownlee and Ward's book on rare earth? And they just, it's like the hackles, flared and they were like, at that time, just wanting to put that book down. They didn't like that. And I think part of it, of course, you had mentioned in terms of all this energy is being used to try to get funding to do all these experiments. And so the premise is to find life in the universe and in a sense to support this material naturalistic perspective. So it's interesting how
That's correct. A lot of narrative are politically more motivated.
yeah, I mean,
If NASA don't follow along the line of this narrative, then how are they going to get funding? How do U.S. taxpayers going to support this finding of the alien life kind of narrative?
right.
No. So
Right. Now their hope is finding life there in the clouds of Venus.
Well, do we have any more comments or questions? It was an excellent presentation and discussion.
Oh, yeah, absolutely wonderful. Thank you so much, David. It's very helpful.
Thank you.
you're
Yes,
welcome.
David, thank you. And then-
I enjoyed putting it together.
and I hope we have access to this.
Oh, yeah, I'll send the slides to David. He can distribute them.
Perfect.
I have it recorded.
Thanks.
And we'll ask David to come back sometime for other topic. Hey Chuck,
Love to do it.
hey Chuck,
And-
Yes,
do you would you close up in prayer for us? Or
sure.
do we have any other announcement?
No, just gonna wish all the fathers a happy Father's Day.
Yeah.
Likewise.
Next month, we'll have Ken Wogemuth, the theologist, the geologist, coming back to talk to us again.
Good.
So this will be July, and then we take a month off in August. And then in September, we'll have Dr. Chung. She was a former NASA, had been working in NASA for 30 years. She will come and talk to us about the moon. And she will have a lot of slideshow. So that'll be interesting.
Great.
So anyway, Chuck, would you close up in prayer for us?
Sure. Dear Word, thank you for the wonders of the world. We got a little glimpse into how fine your procedures and operations are, and what it all took to just give us a place to live out our lives, that we may get to know you in better terms and share your experiences with the people that you put in our lives. Please bring to each of us, put people in our lives, opportunities that we can share some of the messages and lessons that we learned, that were taught here by David this evening. And bless everybody tomorrow as we get with our families. Let the love shine through us to each of our family. In Jesus' name, amen.
Amen.
Amen. Hey, happy Father's Day.
Likewise.
Okay, bye-bye.
Thanks for having me, guys. I really, and ladies, I really, really enjoyed it.
Thank
Appreciate
you,
it.
so
David.
much.
Blessing to come.
Thank you so much.
Thank you
Bye-bye.
so much. Yeah, thank you, David.
Bye-bye.
Mhm.
Oh, I had to twist.